All right, this is Susan Poss again. This is still section 2.5. Remember I said I was going to divide it up into 4 different videos. This group of equations that we're trying to solve involve fractions. So I'm going to still start the same way. I'm going to make sure that we understand left side, right side. I'm going to note that I see variable terms on both sides. So I want to get them together on the same side. I also see constant terms on both sides. So I'm going to move some things around here. I'm going to start out subtracting 1/3 x. Of course, that's going to leave me 2/3 subtract 1/3 is going to leave me 1/3 x. Keep that equals mark in that line. And then I'm going to subtract 1 in order to get the constant terms together on the same side. Whoops, I'm running out of space here. All right, so what do you do when you have a situation like this? Remember we said we're going to always take whatever this numerical coefficient is in front of the variable, and that's what we're going to use as the divisor. So let me come up here where I have a little more space. We'll write this down again. So I'll be dividing by 1/3. Of course, you can let your calculator help you with this division out here. This is called a complex fraction. I'm going to go ahead and write it down. What we're doing is we're taking the numerator and dividing it by the denominator. And when we're doing division with fractions, remember we go into a multiplication operation with the reciprocal or the multiplicative inverse, if we want to talk about some vocabulary here. And so you can see now that when I multiply across the top, I have -21, and multiplying across the bottom, I have +1. You could, of course, write that over +1, but I'm going to choose not to do that. All right, so that's our first one involving fractions. Let me go ahead and take a look at this next one involving fractions. These first two are a little bit easier because you'll notice the denominators are the same. Makes it a little easier to work with. I'm going to show you a different way to work this one. There are several techniques that will work. I'm going to try using the LCD on this one. And of course, the only denominator I see is a 5. And I'm going to use that as a multiplier all the way through this equation. So watch how this one works out, and then you can decide if you prefer this technique. Oops, I don't want to put that in red, sorry. I'm going to keep that in kind of a basic color. So here's my first term. This step that I'm getting ready to do here is called clearing fractions. There's my equals mark. Notice how I'm sort of spreading this out a little bit because I'm going to come in here and insert that LCD as a multiplier. So now I'm going to take my red color. So my LCD is 5. Notice how I'm multiplying each of these terms by the LCD 5. Why would I want to do that? Well, I'd want to do that to clear the fractions. Notice how these 5's in the denominator and the 5 in the numerator cancel out. And so when I look at what I have standing here, this is a 4n. 5 times 2 is 10. The 5 has canceled out there, so this is a 2n. And -5 times +4 is -20. So you can see that I have cleared the fractions. So again, this is another way to handle this. So now I have 2 terms that are variable terms scattered about here, one on the left and one on the right. So let me take care of that. Oh my goodness, that's a messy line, isn't it? And then I'm going to subtract 10 from both sides so that I get my constants together on the same side. Ooh, I'm gonna have to rewrite this. Here's the 2n, here's my equals mark, and over here I have a negative 30. So let me rewrite that. And as we said before, we're going to come in here, and we're going to always divide by whatever that numerical coefficient is. Whoops, sorry, that's supposed to be a 30. So I'm dividing by 2, positive 2, which is going to give me negative 15. All right, so one more, and this is the most challenging one here, because you'll notice in this next and final example on this little video, these denominators are different. So I'm going to use that second technique that I showed you when we look around for an LCD. If you've forgotten how to get an LCD, you can do some reviewing in your textbook. But I'm looking at 2, 4, and 5, and the smallest number that they all divide into without any remainders, or with remainder of 0, is the number 20. So let's replicate what I did before. Remember how I put each term in a little bracket, and the reason I'm doing that is I'm preparing to multiply everything up here. Oops, I forgot my little red dotted line to keep left and right separate. I'm preparing here to multiply through this equation every term in here by that LCD 20, and the purpose in doing that, of course, is that attempt to clear the fractions. And of course, if you use this technique very often, you will not need to write all this down. You'll learn to do a lot of this in your head. Gets kind of messy, so you have to keep your work maybe neater than mine is looking here. All right, so let me highlight. Everything on the bottom now is 1. You see how I've canceled everything out. I've got a 4 times y. I've got a positive 5 times 3. I've got a 10 times y, and I've got a positive 5 times 3. So let me see if I can put all of that together for you. This is going to give me 4y, positive 5 times 3. Here's my equals mark. Here is 10y, and then here is positive 5 times 3. Okay, so now we're back. We've cleared the fractions. We can start moving some things around. And I think I'll just go ahead and do what I've been doing. I'm going to subtract 10y from both sides. Some people like to subtract the other way so that they avoid this negative. That is fine too. Let me come up here and rewrite. So now I'm subtracting 15 from both sides. And you saw one of these earlier. Remember, we're always going to divide by this numerical coefficient in front of the variable. So when I divide by negative 6, I'm actually taking 0 and dividing it by negative 6. And we talked earlier about how that is always equal to 0.